right? And this term was already convergent. And so if I differentiate again, it's going to still be convergent. Okay? So, rule number one, you keep differentiating Feynman loop diagrams with respect to external momenta, and they become more and more ultraviolet convergent. What's that really saying? Actually, you know, I already gave this Wick-rotated form as if all those manipulations were correct. The right way to say it is, if I had first written down the second derivative of sigma as some integral expression, it would have been perfectly well defined, perfectly convergent. You could do all the Wick-rotated expressions, and you would have got the sort of differentiated version of this, and it would have been all perfectly well derived. Okay. And what this says is that the second derivative of sigma, again, the word infinite, finite, what we really mean is insensitive to the ultraviolet. So what this really translates is UV insensitive. So there was a real sigma with all the new physics, whatever it is that makes everything finite, was really in place. And sigma is very sensitive to it. Our little test with Pauli-Vlar says it was very sensitive to that physics. But if you differentiate twice, the second derivative is not very sensitive to the new physics. It's very robust. I don't need to know all that stuff up in the sky. The second derivative is fine. Okay? What does that tell you? Well, we can just integrate this expression twice. We all believed it was finite. If this is just because we're missing whatever that new physics is. I don't know what it is. So the right thing to say is sigma of p squared, the true. Okay? Our attitude is, of course, physics is finite. The true sigma is finite. It's just incredibly sensitive to some new physics way up in the sky. So this, I'm going to say, is finite. That's our attitude. It better be finite. Can't start with the belief that it's crazy. It's finite, but UV sensitive. By which I mean sensitive to some new lambda scale particles which I don't even know. But I can integrate this expression twice. And so what it says is, it has the form A, so there's some integration constants, there they are, there's some integration constants, plus UV insensitive function of p squared. Okay, so you can write it in this form. The true sigma, the thing which we would love to have our hands on, is some integration constants which are UV sensitive. Only in my dreams could I hope to actually calculate them from some fundamental theory. Plus something which is UV insensitive, which doesn't need to know about all those things at the lambda scale. Okay? And this tells you in one shot sort of what the game plan is for the future.
So you mean UV sensitive for A and B?
Sorry, yeah, sensitive thing. The game plan is we need this to do physics. It has this form. These are very UV sensitive. On the other hand, they're just two numbers. They're not functions, they're numbers. Fit them to data. Maybe some of them are conventions about wave functions. So, but whatever is physical here, just fit it to the data. But you get something for free, actually. You get something because you're doing theory here, in the sense that you get a function of p squared predicted in an ultraviolet insensitive way, meaning you can trust it. Okay, as long as the new physics is in fact very heavy, this part is guaranteed. Okay? This part we fit to the data, and then we're in business. Okay, that's the plan. And what we're going to check next time is that as long as the structure has this form, that this form is robust. I never mentioned Pauli-Vlar's here. I just believe there's some new physics. I gave Pauli Villar's was just a vision of what that kind of new physics could possibly be like. There'd be cancellations and heavy masses and all of that, but you get something like this. Okay, so next time we'll take off from there and ask, can we reprove this result just from making this observation? That almost everything in sigma is finite. The parts that are infinite, shouldn't say infinite, you should really say UV sensitive. And if they're UV sensitive, why not just measure them and be done with it? Okay.